Hey everyone, my name is Dennis Lee, and today we're going to be learning about a monotonous stack, also known as a monotonous increasing queue. So, what is a monotonic queue? Basically, it is a data structure where the elements from the front to the end are strictly either increasing or decreasing. Another word for a monotonic increasing queue is also a monotonous stack. We can see here in this picture is like an example of what an increasing queue would look like. So in index 1, we have a value of 5, right? And then in the next index, we have a value of 3. So since 3 is less than 5, the 3 would kick out the 5. We want to go from the lowest to the highest number at the greatest index. And then so in index 3, we have value of 1. The 1 would then kick out 3. And then in index 4, we have 2. And since 2 is greater than 1, we just attach the 2 right after the 1. Same thing for index 5. We have 4, which is greater than 2. So we attach the 4 after the 2. And the same kind of algorithm would keep going on for as many indexes as we need it for. What is a monotonous stack? So basically, like we were saying, we want to find the first element smaller than the current, either in the left from pushing in or in the right from popping out. A stack in computer science is a last in, first out data structure, also known as LIFO. You can think of plates in a cafeteria. The last plate that the people put on the stack of plates will, like when you're cleaning plates, the last plate placed on the stack will be the first one taken off, used by the people in the cafeteria. You can see in this picture here, it's just like a small representation of last number in will be the first one taken out. It'll be on the top of the stack essentially, so it'll be taken out first. You don't want to reach from like the bottom of the stack. Why would we use a monotonic stack? Well, for one, it has a linear time complexity of O of n, so it is rather time efficient. And it's also useful for finding the next slash previous or greater slash smaller element in a list of elements. Additionally, the maximum and minimum elements are kept in their respective orders just due to the nature of the stack. Some real life uses include an undo button for word processors, evaluating math expressions, or solving mazes. You can see in this picture here, kind of visually, how a monotonous stack algorithm would be used to find your way out of a maze. This is depth first, which basically means that we have our starting point. We choose one way, we go all the way until we hit a dead end. And then when we hit a dead end, we go the next path all the way until we hit a dead end. If that doesn't work, then we just take the next path, go all the way, and hit dead end. This is where we're trying to get to. So when we reach that, then we don't need to test out this next path. We've found our path to the end of the maze. So now we're going to take a look at a leak code example that uses a monotonous stack algorithm. It's called daily temperatures. So it says that given a list of daily temperatures called temperatures, return a list such that for each day in the input, it tells you how many days you would have to wait until a warmer temperature. If there's no future day for which this is possible, we just put a 0 there instead. So it says, for example, given the list of temperatures given 73, 74, 75, 71, 69, 72, 76, 73, our output should be 1142, 1100. Makes sense. Gives note that the length of temperatures will be in the range 1 to 30,000. Each temperature will be an integer in the range 30 to 100. Okay. So this is my solution for daily temperatures. Basically, what we did here is that we first have to go through the given array in reverse. So we can see in the conditions for the for loop, and then store the next greater elements index in this array that we made here. Basically, we called it vector of ints called gap. If the stack is empty and the temperatures at the index that we're looking at I is greater than or equal to temperatures at the top of the stack, then we want to pop from the top of the stack, essentially take out. In the case that the stack is empty, we do not find any greater element, and we store 0 And then and then at the end, we want to be able to reverse the whole array and then return our vector of ints called gap. And then that will basically get us our final answer. Yeah, so I hope you guys were able to learn something about monotonous stacks, and thank you for listening.